Hi guys, welcome back to my channel, and for this video, as I promised to you, all of you, we're gonna look at some questions regarding to the linear equations or simultaneous equations. Okay, let's look at the example first. Consider the linear equation. Over here we have m minus 2 times x plus y equals 2 and mx plus 2y equals k, right? And we want to find the value of m and k to give you unique solutions, no solutions, and the infinite many solutions, okay? And if we look at the solutions, this directly tell us what to use CAS to calculate the result or the solutions, right? Solve like the equations involved with literal unknowns. But my method, we don't need this, okay? And it's pretty tedious and it's really hard to understand. And also, if I give you this kind of question in exam 1, which without cannot using CAS, so how do we do it, right? So use the method that I introduced to you guys last video, which is we call the ratio method, right? So it's m minus 2 times x plus y equals 2. Let's write it in this way, and mx plus 2y equals k, okay? So according to the last videos, and we just want to what? M minus 2 over m just equals to 1 over 2, right? So a1 over a2 equals b1 over b2. If we have this ratio be true, it means these two lines are always parallel, right? So once it's parallel, it can be no solutions like this, or infinite many solutions. So exactly the same line twice, okay? So how do we distinguish B and C? Then further we can make it no solution, then just never equal to 2 over k. Infinite many solutions just equals 2 over k, okay? But we can solve for the first case. And for this one, just use 2m minus 4 equals m, and then my m just equals 4. So basically when my m is 4, I can guarantee it is no solution or infinite many solutions, right? So then it's 4 equals 2 over k, which gives me the infinite many solutions. So my k will be equals half, right? So just 2m minus 4 equals m. So my m will be 4, but okay, I'm sorry, I made a mistake over here. M equal 4, but the ratio is just like half over here. So my k gonna be 4 in this case, okay? So it means infinite many solutions, my m is 4 and my k is 4 as well, okay? And for no solutions, again, my m need to be 4, but the half cannot equal 2 over k, okay? Which means k cannot equals 4, okay? Makes sense? So for part B, it's m is equal 4 and k not equal 4, okay? Then for the unique solution, it's pretty straightforward. We just need to make sure these two lines are non-parallel, so which means m cannot equal 4, okay? And we don't really care about the k values because once m is not equal to 4, these two lines are never can be parallel, which means they always can have one intersection. And for different k, just give me the different intersection point. Okay, that's why I want you guys to know this method and apply it for your exercise and final exam. Okay, let's move on a little bit. Let's look at this kind of problem. This one is taken from, 2012 or 2011 exam 1. Okay, it's a long time ago, but it's still worth to see it. Consider the simultaneous linear equation. We got unknown k and two variables x and y, where k again is a real constant. And first, we want to find the value of k, which there are infinite many solutions. Okay, so again, a1x plus b1y equals c1 a2x plus b2y equals c2. So infinite many solution always means a1 over a2 equals b1 over b2 equals c1 over c2. Okay, pretty straightforward. And now we just plug in the number we have. So k over 4 equals to -3 over k plus 7 and equal to k plus 3 over 1. Okay, again, we need to solve for this side. Okay, first, always, because these two can make our two lines are parallel. So we use multiplication is k squared plus 7k equal minus 12, and k squared plus 7k plus 12 equals 0, and then cross product k plus 3, k plus 4 is 0. So currently my k have two values, -3 or -4. Okay, so now I need to check which one give me the infinite many solution and which one give me the parallel one. Okay, so let's go back. We plug in. If my k equals -3, so it's -3 on 4 equals -3 plus 3 is 1 equals 0. So these two are not equal, which means when my k is -3, it's parallel with each other, but it's do not intersect. Okay, so this time I plug k equals 4 inside this function. It's 1 equals, I might make some mistakes. K is 12 plus k squared. Okay, oh sorry, k equals -4. Yep, I made a mistake over here. So always check your answers. So k is -4, it becomes -1 over here, and it's equal to the right hand side -4 plus 3 over 1. So again, it's -1. So these three equations are all equal. So when my k is -4, it's infinite many solutions. Let's check. We plug back in these two equations. We have -4x minus 3y equals -1, and k code is 4x and plus 3y equals 1. So you can see that this equation are identical because you times -1, you get the bottom one. Okay, both sides times -1. Okay, because we did find k equal -3 or k equal -4 for the first case, so in this case they ask us about the unique solution. Unique solution means only one solution, right? So we need to get rid of the infinite many solutions, which in this case is k equals -4, and we need to get rid of the parallel in this case, which is k equal -3. So our final answer could be right like this. K belongs to R, and slash, I don't want -3 and -4. Or you're gonna say, sir, I'm not really confident about writing like this. So we can write it another way, like -infinity to -4, small brackets, union -3 to, -4 to -3, use small brackets, union -3 to infinity. Okay, this is another way to write your final answer, but just need to make sure you can and you answer your final answer is a set. Okay, this is pretty important. Okay, we cannot really give the inequality like k not equal to 3 and k not equal to 4. Okay, and k not equal to 4, -4. This is not they want. Okay, they want a set because we have learned it. Okay, and this is the topic and this is the practice I want to cover for today. Again, let's just quick wrap up. For this simultaneously linear equations, just make sure you write your form in ax plus by equals c. Okay, ax plus by equals c for both equations. Then you make the corresponding ratios are equal. In here, just make A1 over A2 equals B1 over B2 equals C1 over C2 gives us infinite many solutions. If we have A1 over A2, B1 over B2, but not equal to C1 over C2, gives us parallel. And the rest of all the cases, okay, gives you like the intersection, okay, which means unique solution, okay. I hope this video is helpful, and if you like my explanation and like my channel, please subscribe and click the like button. And that would be end for this video. Okay, I see you guys for the next one. Okay, bye bye guys.